Why is x 4.0 faster than x4 in Python 3? Why is x 4.0 faster than x4? I am using Python 3.5.2. I tried changing the power I raise by to see how it acts, and for example if I raise x to the power of 10 or 16 it's jumping from 30 to 35, but if I'm raising by 10.0 as a float, it's just moving around 24.14. I guess it has something to do with float conversion in powers of 2 maybe, but I don't really know. I noticed that in both cases powers of 2 are faster, I guess since those calculations are more native/easy for the interpreter/computer. But still, with floats it's almost not moving. 2.0 equals 24.14 and 128.0 equals 24.14 but 2 equals 29 and 128 equals 62. Tiger Octbase.
Why is x 4.0 faster than x4 in Python 3? Python 3 int objects are a full-fledged object designed to support an arbitrary size. Due to that fact, they are handled as such on the C level. See how all variables are declared as pylong object type in long_pow. This also makes their exponentiation a lot more trickier and tedious since you need to play around with the ob_digit array it uses to represent its value to perform it. Source for the brave. C. Understanding memory allocation for large integers in Python for more on pylong objects. Python float objects, on the contrary, can be transformed to a C double type by using pyfloat_as_double, and operations can be performed using those native types. This is great because, after checking for relevant edge cases, it allows Python to use the platform's POW, C's POW, that is, to handle the actual exponentiation. Where 4 and I are original pyfloat objects as C doubles. For what it's worth, Python 2 July 2013 for me is a factor 2-3 faster, and shows the inverse behavior. The previous fact also explains the discrepancy between Python 2 and 3, so I thought I'd address this comment too because it is interesting. In Python 2, you're using the old int object that differs from the int object in Python 3. All int objects in 3.x are of pylong object type. In Python 2, there's a distinction that depends on the value of the object, or, if you use the suffix ll. The type int you see here does the same thing floats do. It gets safely converted into a C long when exponentiation is performed on it. The int_pow also hints the compiler to put them in a register if it can do so that could make a difference. This allows for a good speed gain. To see how sluggish type long s are in comparison to type int s, if you wrap the x name in a long call in Python 2, essentially forcing it to use long_pow as in Python 3, the speed gain disappears. Take note that, though the one snippet transforms the int to long while the other does not, as pointed out by @Pydsinger, this cast is not the contributing force behind the slowdown. The implementation of long_pow is time the statement solely with long x to c. It doesn't happen outside of the loop. Any idea about that? This is Python's peephole optimizer folding the constants for you. You get the same exact timings either case since there's no actual computation to find the result of the exponentiation. only loading of values. Identical byte code is generated for 44. With the only difference being that the load_const loads the float 256.0 instead of the int 256. So the times are identical. All of the above applies solely for Python, the reference implementation of Python. Other implementations might perform differently.
If we look at the bytecode, we can see that the expressions are purely identical. The only difference is a type of a constant that will be an argument of binary_power. So it's most certainly due to an int being converted to a floating point number down the line. Update. Let's take a look at object/abstract in the Python source code. Penumber_power calls ternary_, which is too long to paste here, so here's the link. It calls the nb_power slot of x, passing y as an argument. Finally, in float_power, line 686 of object/float_object, we see that arguments are converted to a C double right before the actual operation.
Because one is correct, another is approximation.
If you wanted to see more, please consider subscribing.